Let me show you how to do the vertical acceleration for something like the spider. The spider is a little bit more challenging, okay, because it also moves to the side, okay? So what we're going to do here first is get a distance reference for the spider. And for this one, we know that the fence, these little posts, are actually 2.04 meters. So I'm just going to kind of write that down, 2.04 meters. 2 meters is probably close enough, right? Okay. And then we just need to find a video and open up that video analysis app. So click on the key, right? And then you can run the app like that. And then we're going to choose our file. And for me, I think I got to do this. I don't know why. I still don't know my way around the Mac. Okay, here it is. Videos for Oaks Park. Let's look at the spider. Sorry. Let's try that one. Okay. So I know that I want to do the system here. And I know that these fence posts are 2.04 meters. Now the thing is, the fence posts are not quite the same distance. 2.04. They're not quite the same distance, you know. But the problem is these cars are rounded. It's very hard to do accurate stuff there, right? And then one frame, that's probably too much. 2 frames, every 2 frames might be good. And then let's just take a look at this and we'll play it. You can see the rides, they kind of plunge down in front of us. And what we want to do is follow one of these things and get a good plunge-worthy. Oh, there's a good one right there. Okay, I feel like if we follow this car right there, okay, I think it goes down. Let's just start at the beginning. Okay, yeah, right from the beginning, I think we've got some good data here. What car are we going to follow? You got to pick a car, right? I think maybe this guy right here, okay? All right, so I'm just going to do my usual trick. I think in this case, I'm going to touch the top of that car with my... And this is clearly more difficult than the frog hopper because there's some motion here, right, that's going to mess us up. It's moving to the side as well, right? Okay. So there I am. I've got the car, it's gone down. It's about to go up, I feel like. Don't you feel like it's going to go up? It's also getting like farther away from us too, you know, as it goes around. So you kind of want to get them as they go along the front. And by the way, we don't really care about the X on this. And now it's kind of hypothetical, like what am I actually clicking on? But I've got a nice upward acceleration here. So I'm just going to stop. Now I don't care about the X. In this case, I just care about the Y. Okay, and then let's make this as big as we can. And here's a nice upward acceleration. So let's just grab that guy here. I'm going to grab it from like here to about here. Okay. And then I'm going to stick the curve fit on here. Linear is not so good. Quadratic is really nice. Okay. And there you go. You can see that I've got that half of the acceleration seems to be about 4. Right. So this thing's accelerating up at about 8 meters per second squared. Because remember, this coefficient A is half your acceleration. So that's an example of an upward acceleration. Now to get a downward acceleration, what we're going to need to do is do the same thing over, only we want to figure out, well, for this video, we could actually use this part here, right? Okay, so let's get rid of this. We could actually use this part. This is a nice downward acceleration right here. Same thing, right? View, apply a curve fit, and then we're going to do quadratic, and then say apply, and then you can see the downward acceleration there. I would rather have a whole thing like this, okay? So what I think I'm going to do is just start over again, okay? So let's find a spot in this. First, I think, let's find a spot where something's going over the top in front of us. Okay, there it is, right there. See that guy? Okay, this guy is going right over the top for us, okay? So let's go. So again, I'm just using the top of the crosshairs to click on it. I don't really care really about the X. And of course it's, you know, it's curved, it's slanted. Do the best you can, okay? So now we've got a nice downward acceleration. Notice I didn't bother to analyze what it did in between. It's totally a different car, but I'm not going to worry about that too much. I'm just going to stick a curve fit on this, right? So here's a downward acceleration. Probably from there to there is good. And I want to do a curve fit. I want a quadratic, and I want to apply that. And there you go. As you can see, it's got a fairly subtle downward acceleration. It looks to be about negative 3.6 or something like that. So, you know, and I don't know if that's real. I don't know if it really accelerates down more slowly or whether that's just the result of the video analysis. But that's the gist. That's what we're going to do. All right. I think that's all I'm going to say.